Thank you. Well, thank you very much. I'm going to teach on a very important lesson today, lesson 8.3, the slope of a line. It's important because much of the remainder of this unit depends on your understanding of what slope of a line is and how to use it to help you. It's also definitely on standardized test, ACT, SAT, and our proficiency. Now, I've drawn a very rough picture of a house there, and on the roof, you may notice I've got some little dotted lines here and dotted lines here. How a roof is slanted, people that put roofs on for a living describe that to know how steep or how it's sloped. And they compare the rise in the roof to what they call the run in the roof. The rise is up, down, the run is right, left. So as you can see here, my rise and my run gives me a description on how the roof is slanted. In fact, over here, notice I call this slope. Slope is the rise compared to the run. It's a ratio, just like we had in the last unit. It's the rise to the run. Now here's an example. My roof has a rise of 3 feet and a run of 12 feet, and I want to find the slope. Well, my slope would be the rise compared to the run. So it would be 3 to 12, which simplifies like a fraction to 1/4. And we would say the slope of that roof would be 1/4. Now, here's a better description and a way to find the slope of a line. Given 2 points on a non-vertical line, you can find the slope, and we use the letter M, lowercase letter m for slope. It comes from a French word, montir, which means to climb, like to climb the slope of a mountain. To find the slope M of the line using the formula, M equals rise over run, or it's the difference in the y coordinates over the difference in the x coordinates, because it's the y coordinates that describe vertical change, it's the x coordinates that describe horizontal change. So it's the change in the y's over the change in the x's, the difference of the y coordinates over the difference of the x coordinates. So I've given an example here where I have 2 very arbitrary ordered pairs. I call this x1, y1, and this one x2, y2. And I say that slope is the difference in the y coordinates. Notice I go to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Notice how I'm consistent. The 2's are first, the 1's are second. Now if I switch them around, top and bottom, I have the 1's first and the 2's second, it'll still work. But there's a stipulation that the x sub 1 and the x sub 1 and the x sub 2 cannot be the same number, because if they are, then you get 0 in the denominator, and that's undefined. But we'll talk about that with an example. Now let's try an example of finding the slope through the line that goes through the 2 ordered pairs, the points described by 3, 1, and 5, 4. So if I call this x sub 1, y sub 1, and I call this x sub 2, y sub 2, my slope would be 4 minus 1, 4 minus 1, y sub 2 minus y sub 1, look right up here, y sub 2 minus y sub 1, 4 minus 1, all over 5 minus 3, 5 minus 3. That's the x sub 2 minus the x sub 1. So the x sub 2 and the x sub 1. So now I subtract in the numerator, I subtract in the denominator, and I get 3 over 2. That's the slope of the line that goes through those 2 points. If I was to graph these 2 points on the Cartesian plane and draw a line that goes through them, the slope of that line would be positive 3 over 2, the rise over the run. Now if you're wondering, should I change that to a mixed number? No. We usually leave slope as a ratio, as a fraction. The exceptions are if this slope turns out to be an integer, like 5 or negative 2. But we'll do some more examples. Okay, in general, if the line that we're interested in goes up and to the right, the slope is positive. Up is positive, right is positive. Up and to the right, positive over positive, which is positive. If the line goes up and to the left, up is positive, but left is negative, that would be a positive over a negative, that's negative. So up and to the right, positive slope, up and to the left, negative slope. If the line is exactly horizontal, then we say the slope is 0. Okay? Not no slope, the slope is 0. If the line is vertical, a vertical line, like that, then we say that the slope is undefined, which means essentially that there is no slope. Now, no slope and zero slope are two different things. If the slope is zero, it's horizontal, but if we say they have no slope, then it's vertical. Here's a couple of examples of lines, not very well drawn, but that I have graphed out here, and I'm going to find the slope two different ways. All right, the first way I'm going to find the slope is I'm going to count rise and run. Now, I know that since this line goes up and to the left, my slope is negative. I have 2 points here and here. From this point to this point, I'm going to go upward, downward, then I'm going to go right, left. So I have to go up one spot, that's positive one because it's up, and then I would have to go left 3 spots. Since it's left, it's negative. So my slope is up 1, left 3, or negative 1/3. The negative in the denominator is the same as the negative if it was just in the numerator, or we just normally put it out in front. Okay? The second way I'm going to find that slope is by using the slope formula. It's the difference in the y's over the difference in the x's. Okay? The difference in the y's, this would be my x1, y1, this would be my x2, y2. It would be negative 2 minus negative 1. Be careful with all those negatives. All over 3 minus 0. Well, subtracting a negative is the same as adding the opposite. This is negative 1 over 3. It's the same answer. Okay, now on the one on the right, I'm just going to count rise over run. I'm not going to do the slope formula because I have some more of those anyway. I'm going to go from this point to this point. Now my line goes up and to the right, so I already know my slope is positive. I already know that. But I start here. I'm going to go up 1, 2, 3. Up 3 is positive. That's 3 there. Then I'm going to go right 1, 2, 3. Be better if it was on a grid. And 3 to the right is positive. So it's up 3, right 3. Now 3 over 3 simplifies to 1. And that's one of the only exceptions, that's the only kind of exception when you don't write it as a fraction, because this is an integer and we can write it as a single integer. 1, of course, means the same thing as 1 over 1. So we can always think of 1 as a fraction, any integer as a fraction, by putting it over 1. Here are 4 examples where we're going to use the slope formula. I've written it down again, and we're going to find the slope of the line through the points. The slope formula, the difference in the y's over the difference in the x's. Really important to remember that. I'm going to call this x1, y1, this x2, y2. So my slope is equal to 1 minus 5, all over 6 minus negative 2. Now be careful with your subtractions, especially when it involves negatives. Think of subtraction as adding the opposite. I have a negative 4 on top, adding the opposite, and I have a positive 8 on the bottom, and that's negative 1/2. You can divide top and bottom by 4, reduce your fraction. Here, if I call this x1, y1, x2, y2, my slope is negative 12 minus 6, all over 8 minus negative 13. Again, 2 non-traditional subtractions. Change it to adding the opposite, change it to adding the opposite. So this is negative 12 plus negative 6 is negative 18. 8 plus 13 is 21. Now this doesn't give me an integer, but it does reduce because I could divide top and bottom by 3, and I get negative 6/7. The next example, this is my x1, y1, this is my x2, y2. My slope would be this y2 minus this y1, 4 minus 4, all over 5 minus 2. So that's 0 over 3, which of course is 0. So the line that goes to these 2 points is horizontal. If we graph these 2 points, draw a line that connects them, it will be a horizontal line. The 0 can be in the numerator. Remember, it can't be in the denominator. Now this last example, I'll call this x1, y1, and this x2, y2. And my slope would be negative 1 minus 5, all over 1 minus 1. That's negative 6. It's like adding the opposite, all over 0. There again, cannot divide by 0. So this is undefined. The slope is undefined, which means that if I graphed these 2 points and drew a line that went between or connected them, it would be a vertical line. The slope is undefined. Okay, we're going to do a little bit more, some of the same stuff. We're still going to use the slope formula here. Find the slope of the line through the given points. That's that y sub 2 minus y sub 1 over x sub 2 minus x sub 1 we just did. But this time we're also going to tell whether the slope is positive, negative, 0, or undefined. But we'll be able to tell that from the slope itself. So my slope here is going to be 5 minus 3 all over 4 minus 2. 5 minus 3. Notice I didn't even write the x1, y1. I'll go ahead and do it now. But 5 minus 3, 4 minus 2. After you've done enough of these, you won't have to write it down every time. You'll know right minus left, right minus left. So that's 2 on top and 2 on the bottom, and that's a positive 1, and definitely that has positive slope. The next one there, x sub 1, y sub 1, x sub 2, y sub 2. Slope is negative 1 minus 3 all over 6 minus 6. That's like adding the opposite. I'm going to get negative 4 all over 0. Now again, you cannot divide by 0. If you divide by 0, worlds collide. Bad things happen. It will definitely be a bomb. So what we do is we do not write that this is 0. It's not equal to 0. This is undefined. And there we go. Next one. X sub 1, y sub 1, x sub 2, y sub 2. My slope is 4 minus 4 over 5 minus a negative 7. So that's going to be 0 on top. It really doesn't matter what's the denominator because 0 over any non-zero number is 0. As it turns out, this is 12, and this is equal to 0, which of course is 0. Now, these are two special cases. Remember, these are vertical lines that go through these 2 points. This is a horizontal line that goes through these 2 points. So if I say find the slope of the line shown, for A, it's horizontal. The slope is 0. For B, it's vertical. The slope is undefined. Or again, we can call that no slope. It's important that you learn how to find the slope and what the slope tells you about the way a line is slanted. This is not every single kind of problem that involves slope, but these are the basics, and it's important to understand this as you work through these next sections. So remember, practice, practice, practice.